questions in period 3. Good luck at tomorrow's test. Class is over. On the test, but I guess now luck is going to be involved. Everybody can do 4, 5, 6, 7, 8. Because 1, 2, and 3 I taught you yesterday, right? Just to put it on the video, right? You figure you want to ask, right? Okay, abstemious. How many letters does abstemious have? 10 letters, okay, and we're going to make a word, so this is a permutation. So 2, 3, 4, 5, 6, 7, 8, 9, 10. But the restriction is the vowels have to appear in alphabetical order. Okay, so let's do a specific case. Where do you want to put the vowels? The first 5 positions, I guess? Vowel, 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 or you want to put a straggler out there? It doesn't matter. You got to make a specific case, and then you multiply by the number of cases. That's the key. So if these are the vowels, how many choices do I have? 1. Because they have to be in alphabetical order. So the A has to come first. So you 1, 1. Does everybody understand that? Because that's the A, E, I, O, and U. They have to appear in order, that's why. So that's why 1, 1, 1, 1, 1. Now what about the 5 consonants? How many choices do I have? Consonants, there's no restrictions, right? Okay, but this is just the case where the vowels occur in positions 1, 2, 3, 4, and 7. What are the other cases? Well, the vowels can appear in, let's count them up. 1, 2, 3. Or 8, and just keep writing them all out. That's crazy. Now that we know combinations, what is it? What's multiplication factor? Out of these 10 positions, how many ways can I pick 5 of them to be the vowels? 5. That's how many cases there are. Right? Because every time you pick 5, that tells you where the 5 vowels are. It's like here, 10 candy bars. How many ways can you pick 5 of them? Because every time you pick 5 of them, that tells you where the 5 vowels are. Just when you think you got it, no. You have to divide the whole thing by 2 factorial. Why? Because there's 2. Right? When you have repeated letters, you got to divide by the number of repeats factorial, right? So do you think I can come up with another word tomorrow that has 5 vowels in it? Now that I told you that. At least facetious doesn't have repeated letters like abstemious. Yeah? And you guys, anyway, isn't abstemious on your vocab list that you guys just took? Should be. Number 5. I'm just going to teach you, there's many ways of doing this problem. I'm just going to teach you the short way. In the World Series, 2 teams, A and B, play each other until one team has won 4 games. You guys know that, right? So what is the maximum number of games that can be played in a... It doesn't matter if it's World Series or NBA championship, right? Best, whoever wins 4 first is the winner, right? So what is the maximum number of games that can be played? 7, right? Answer. 7, choose 4. Here are the 7 games. 1, 2, 3, 4, 5, 6, 7. How many ways can I select 4 of them for Team A to win? Or another way to think about it is, it's okay, we want Team A to win, right? Okay, so A, B, A, B. It's like, how many 7-letter words can you make with 4 A's and 3 B's? Every time you make a word, that tells you who wins which game of the series. So like if this is the word, what does this mean? Team A wins game 1, 2, 3, 5. Of course, once Team A wins the 4th one, you really don't care about that last 2, right? Because they won already. But but it's like a 7-letter word with 4 A's and 3 B's. So how many words can you make? Factorial, but I see 4 A's. 4 factorial, 3 factorial. Hey, that's the same thing as 7 choose 4. It's also the same thing as 7 choose 3. Because out of these 7 games, how many ways can you pick 3 of them for team B? 3, which is the same as 7 choose 4, which is the same as that. See how they're all related? So tomorrow, what if you had 5 out of 9 games? Okay, now number 6 was pretty easy, wasn't it? Yes or no? Height or yay? Height or yeah. Are you joking? 6A? You couldn't do 6A? Go to your room right now. How many total people are there? Can't even count how many people. Okay. I can't play that game. We're going to have another person in our class next quarter, you know, having a transplant. So that to inspire you guys to talk. CO. Okay. How many ways can you put the 7 people? Can you put 7 people around a circular table? We learned this yesterday. 6 factorial, it's n minus 1 factorial. Now, do you think you can get a problem that simple tomorrow? No way. No, there's going to be restrictions. Okay, what if Betty and Fran must sit next to each other? Now, what did I tell you yesterday? If people have to sit next to each other, make a love bench. Okay, just bench then. Here's Betty and Fran. And then there's 5 other people, so 5 individual seats. So how many things are around the circular table? There's. But on this bench, get 2 people. How many ways can they be arranged? 2 factorial. And Ellen and Google must be sitting together. So again, you make a bench with 3 people on it, and then you have 4 individual seats. There are around the table. 5. How many ways can I arrange 5 things around a circular table? 4 factorial. But on this bench, got 3 people. How many ways can they be arranged? 3 factorial. See, it's really quite simple. Now, what happens if Betty and Fran have to sit together, and the other 3 people got to sit together? Benches, and then you need 2 individual seats. There's 4 things around the circular table. How many ways can that be arranged? Factorial. But on this bench, get 2 people. That bench, get 3 people. And I'm assuming you guys read the example, so you guys know the keychain problem, right? And I'm going to mention it since who knows what might appear in tomorrow's test. Let's say, how many keys are on a keychain? Let's say you have 6 keys on a keychain. You guys know what a keychain is, right? Well, I don't know. Sometimes you guys just, I don't know.
Yes.
Okay, there's 6 keys on a keychain. 1, 2, 3, 4, 5, 6. How many ways can you arrange them? Well, isn't that like a circular table? So you might think, oh, since there's 6 keys, then there'll be. No, Moose Breath, you gotta divide by 2. Yeah, because a keychain, you can turn it over. That's why like this. Whereas a table of people, you cannot turn a table of people over. You guys understand why you gotta divide by 2 on the keychain? Play that game again, huh? Waste another minute. You gotta get through a lot of problems, people. You You guys, otherwise you're gonna be on your own. You're gonna be floating in the Pacific Ocean. Okay, how many rectangles are there on an 8x8 checkerboard? How many people got it? How did you get it? Cubes? What are you talking about, Willis? Okay, now there's lots of ways of doing this problem. Actually, I subbed in the lower school one day because one of the teachers was sick, and then I gave them whatever homework you were assigned. Don't do that. Do this problem. Of course, when elementary school kids do it, they do it differently than we do it, right? So count all the 1x1 squares, then count all the 1x6, 1x7, 2x2, 2x3, 2x4, and just count them all and add them up. Nobody got it. One girl got kind of close, but she miscounted. Okay, but we are a sophisticated level, so we're not going to do the method of exhaustion, right? Okay, now here, watch this. This is so beautiful. No matter what rectangle I make, okay, let's say it's a rectangle right here. Do you agree a rectangle has to have a left side, a right side? How many vertical lines do you see on this checkerboard? How many ways can I select two of them to be the two sides? How many horizontal lines are there? How many ways can I pick two of them to be the top and the bottom? Because every time you make a rectangle, you have to make a left side and a right side. So out of the 9 vertical lines, once you select 2 of the vertical lines, like these two, that determines the left and right borders of the rectangle. And same thing with the top. Out of these 9 horizontal lines, how many ways can you select 2 of them? 9 choose 2, right? Because once you select 2 of them, that determines the upper and lower borders of the rectangle. Square, same thing, right? Like a square like here, wait, that square right there, right? You still have a left side, right side, top and bottom. It doesn't matter, you pick a left, right, up and down, that forms a rectangle. You didn't know a square is a rectangle? The definition of a rectangle is a quadrilateral with 4 right angles. That's the good job. So this is 36 times 36, 1296. Now in mathematics, what do you call a surprisingly simple solution to a difficult? It's called elegant. We call this solution elegant. Surprisingly simple way to solve a difficult problem. And mathematicians, this is what they strive for. Because there's lots of ways of doing the problem, but the person who does it the most elegant way is going to be the more. Because you can just count them all, right? But that's just brute force, right? What if I make a 100 by 100 checkerboard? You going to count it like that? No, you want an elegant way of doing it, and this is it. Okay, number 8. How many people got it? So is that, how did you do it? Number 8. Algebra or elegance? So only one person. I'm putting this on. This is on the test. Okay, before we even go any further, okay, what time is it? We're not going to even get to the problems. You guys are in trouble. What is the definition of A choose B before we even do this problem? A factorial over B factorial gotta do is apply the definition here. Just apply it. I'll give you 1 point tomorrow if you do that. What is this? N minus 1 factorial over this factorial, which is r minus this minus that factorial. What is this minus that? This is equal to n minus 1 factorial over r factorial, and then this minus that factorial. So n minus r minus 1 factorial. Okay, the least you should have done is that, right? Because that's just applying the definition. Okay, now. The hard part. When you go to BC Calculus next year, you have to be able to work with factorials. Now, somebody came in for help this morning. They add these two fractions together. You know what their least common denominator was? This times this. No! This is the least common denominator. R factorial, n minus r factorial. It is not just all four of them multiplied together. It's just like this, look. When you add 1/8 plus 1/4, is the least common denominator 32? No. What is it? Do I just multiply them? No, it's 8. Because 4 goes into 8, that's why, right? 4 is a factor of 8. Same thing here. When you look at this and this, what is, okay, first of all, what is r factorial? What does r factorial mean? R times r minus 1 times all the way until you hit 1, right? What is this? That's r minus 1 factorial. See? R minus 1 all the way until you hit 1. R minus 1 factorial is a factor of that. That's why r factorial is the least common denominator. You guys better stare at this. And same thing here. If you have this one and this one, what's the least common denominator going to be? Minus r factorial, because this is included in that, that's why. Because what is this equal to here? Someone's going, what? N minus r, then you just keep subtracting 1 all the way until you hit 1, right? But then, what is that right there? That's this is a factor of that. Okay, now, tell me, once we know the least common denominator, what goes up here? What do I need to multiply top and bottom by this fraction? Yeah, just multiply top and bottom by r, because r minus 1 factorial times r will give you r factorial. Now what about this one? What do I need to multiply top and bottom by to get this denominator here? Well, r factorial was there already. What do I need to multiply that by to get this? You better stare at this. No, just take the minus 4. There you go. And then now all you got to do is simplify it. What can be factored out in the numerator? R plus all over r factorial n minus. Oh, but the r's cancel out. And then what is n times n minus 1 factorial? N factorial. Hey, you somebody. That's n choose r. Yeah, tears of pain. The part, there's got to be an easier way. Yeah, okay, but here, okay, here's the elegant solution. That's the ground and pound way. Watch this, okay. Okay, Pascal's triangle. What are the numbers in Pascal's triangle in the 4th row? Tell me. No, just go 3rd row. What are the numbers in the 3rd row of Pascal's triangle? 1, 3, 3, 1. Yeah, but 3, 2, 0, 3, 3, right? 1, 3, 3, 1. What are you doing? Sit down. What are the numbers in the 4th row of Pascal's triangle? 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4, correct? 1, 4, 6, 4, 1. And how does Pascal's triangle work? Like, how do I get this number here? Don't you add the two numbers above it? Remember how Pascal's triangle You add these two numbers, you get that. You add these two numbers, you get that. You add these two numbers, you get that, right? So, erase this. Look at that. Hey, these are the numbers in this triangle. This is the third row. This is the fourth row. What row is this? Look, this is the third row. This is the fourth row. What row would this be? This is the n minus 1th row right there. And how do I know they're like next to each other? Because they differ by 1. Look, if that number is 1 less than that number, then they're right next to each other, right? This number is 1 less than that number. So these two numbers are right next to each other in the n minus 1th row. So if I add them together, I'm going to get the one that's right here. I get that one right there. So if I add these two, I'm going to get the one that's right here, which is what? N, right? Because if this is the n minus 1th row, that's going to be the next row, which is n. Then what? What's the pattern? If I add these two, you get this. I add these two, you get that. I add these two, you get that. How do I figure where this bottom number comes from? The one on the right. So if I add these two numbers, what do are finished. Okay, so tomorrow's test, I already made it. So instead of 18 problems, I made 15 problems. You get 3 pages of 5 problems. So 4 points each, you can get 43 points on this test. And I dumbed it down, because usually I put 3 or 4 problems where you got to really think, but I took those out. But some of you still think it's going to be super hard. Because you're not keeping up. Okay, let's do the handshake problem. How many people in this class? 3. What did I just say? 12, 14, if you include me, 15. 15 people in this class. If everybody shook hands with everybody else exactly once, how many handshakes took place? Think about it. You have 15 people here. Every time I select 2 people, that's a handshake, right? Doesn't a handshake consist of 2 people? You have 3 people put their hands in and they go like this. No, just 2 people. See how simple that problem was? I just want to make sure you know that, because maybe there's a hand. Okay, now I circled some problems on here that are going to help you on tomorrow. I'm going to write it on the board so the camera can see. So on combinatorics 4, these problems might help you. 1, 4, 5, 6, 7. And on combinatorics 5, I'm not going to tell you everything, and 8. Well, actually, if I were you, if you have time, I would just do them all. Anyway, this is how BC calculus is next year, you know. There's no practice. Exactly, depends what teacher you have. You have AV. Okay, let's do some. Try and go through these as fast as we can. Okay, number 3. This is combinatorics 4. How many ways can 9 different candy bars be distributed to 3 children if each child receives 3 candy bars? See, this is how you gotta think. Hey, we did a problem like this before. Remember Mo, Larry, Curly? Now I don't give them any names, you can't do it. Okay, is this a permutation or a combination? Okay, there are 9 candy bars on the table. The first kid goes up, take 3. 9 choose 3. Candy bars left. Second kid, take 3. And the third kid, take whatever you want. 3 choose. Last kid got there's only 3 left on the table, right? So write that down on your paper. See, this is, I don't know, if you're bad at arithmetic, maybe you should just write that on your paper, go to the next problem, right? Oh, and then go back and then compute it later. Because if you spend like 2 minutes just computing this number, you get it wrong anyway, right? You know what I'm talking about? It's only 1 point for the computation. Okay, number 4. How do you do this problem again? You gotta make different cases. You gotta make the 2 cases. One case where the last digit is 0, and another case where the last digit is not zeros. If you don't make those 2 cases, it's a fatal error already. Okay, we know how to do number 5, right? Make the bench. Okay, number 6. Hey, now it's on the quiz. Why am I saying that when Miyoko never took it yet? Number 7. Number 7. Okay, we did a problem like that already. How many ways can Jason take at least one of them to college with him? So what? How many ways can he take one calculator with him? 6 choose 1. How many ways can he take 2 of them with him? 6 choose 2. What about 3? 6 choose 3. 6 choose 4. 6 choose 5. How many ways can he take all 6 of them to college with him? Write that on your paper, you get 3 out of 4 points right there. But then, wasn't there a fast way of computing this? Remember I told you? What happens when you add all the numbers in the 6th row of Pascal's triangle? You get 2 to the 6, but what's the one that's not listed here? 6 0, which is what? 1, minus that 1. Well, whatever. Or just compute those darn numbers. How hard is that? These are small numbers. Better do number 8. Logarithm. How many 5-letter words? Okay, you read that already. 5-letter word. Is this a permutation or a combination? The order is important, right? Can be formed using the letters of the word logarithm if each word must contain at least 2 vowels. Well, how many vowels are there in logarithm? There's only 3 vowels, so it has to contain at least 2 vowels or 3 vowels. Or is it better to do the complement? What's the complement at least 2 vowels? 1 vowel and no vowels, and then subtract that from the total. No, you don't want to do that. That's 3 computations. There's only 2 computations, right? I think you just compute it directly. Okay, now there's 2 ways of doing this. What time is it? Okay, so how many letter word? 5-letter word. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 2 vowels. Well, let's put the 2 vowels in the first 2 positions right here. How many choices do I have? 3 and 2, because there's consonants, so how many choices? Say 4. But this is just the case where the vowels are in positions 1 and 2. Out of these 5 positions, how many ways can it be? Or if you want to count it out, you can go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Count it by hand, I don't care. That's the same thing as 5 choose 2. Gotta multiply by the number of cases. Now what about 3 vowels? Here are the 3 vowels right here. How many choices do I have? 3, 1, and then the consonants. 6, 5. But is that the only case the vowels go in positions 1, 2, and 3? No. So what is it? Or you can count them. They can be in positions 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 3, 4, 1, 3, 5, 1, 4, 5, 2, 3, 4, 2, 3, 5, 2, 4, 5, 3, 4, 5. That's 10. Or you could just go 5 choose 3. Or how about, now can you see why 5 choose 3 is the same as 5 choose 2? Because 5 choose 2 would be, out of these 5 positions, how many ways can I pick 2 of them consonants? And there's lots of ways of thinking about it. Vowel, 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 consonant, consonant. How many 5-letter words can I make with 3 V's and 2 C's? 5 factorial, but then get 3 V's, but then get 2 C's. Yeah, it's the same thing as 5 choose 3, which is the same thing as 5 choose 2. It's all related together. Or, Here, let me show you another way to do it. What time is it? Oh, no. Never mind. Just do it that way. There's always lots of ways to do problems. That's the beauty of combinatorics. Okay, look at combinatorics 5. Hurry up. We're in trouble, people. That's all I can tell you. We did that problem. Okay, the ones I said. Okay, look at number 5. How many ways can one order 10 entrees of chicken, beef, pork, and or fish? So like you're calling up the restaurant. Can I get two? Where's the thing? Can I get 2 chicken, 2 beef, 2 pork, and 4 fish? How many ways can you order? Like you have 10 balls. Suppose you have 10 identical balls. You're going to put them into 4 boxes. And what are the boxes? Chicken, beef, pork, and fish. Do we know how to put balls in boxes? Yes. So how do we do this problem quick? Yeah, how many sticks? 3 sticks. So if you have 10 O's and 3 I's, how many 13-letter words can you make? 13 factorial over 10 factorial, 3 factorial. But you got to recognize that as the balls in the boxes problem. And then look at number 8. We got time for one more. Let's try to squeeze this in on the video. I'll tell you right now, got a problem like this tomorrow. This is 1 out of 50. Okay, compute. Now, how do you want to compute and choose 2? You want to use the formula or the shortcut I taught you? What do you want to do? Just use the shortcut. How do you compute n choose 2? You put 2 times 1 on the bottom and n times n minus 1 on the top, right? All the other stuff cancels out. How do you compute something choose 3? You put 3, 2, 1 on the bottom and then n plus 2, n plus 1, n on the top, correct? Now it's algebra 1. Solve this equation. How do you solve this equation? 2 goes into 4 2 times. This is 6. Multiply both sides by 6, so this becomes 12, right? So this is what I got. 12n, n minus 1. Can I divide both sides by n? Yes. Well, what's the solution I'm losing by doing that? N equals 0. But can you see 0 cannot be a solution? Is there such thing as 0 choose 2? No. When you do this choose notation, this number got to be greater than or equal to the bottom number. So just solve this equation. 12n minus 12. Let's see if we can do it before the problem. N squared plus 3n plus 2. Woo! Quadratic. N squared minus 9n plus 14. Woo! N minus 2, n minus 7, n equals 2 or 7. Are these the 2 answers, or do I have to cross out one of them? Remember, this number has to be greater than or equal to that number now. Otherwise, it's not be problem. Okay, I dumbed down the test as much as I could, and you're getting 43 points. But you still got to know something. So I'm not the only one telling you. So for real, you're lucky that there was a 5-point problem on the last meet, right? We had a big discussion on the grading table about that. And people simply want to just give you the wrong, because we're working on the wrong. Because no, the rule is, when we decide whether the answer is acceptable or not, we cannot look at what your work is. We just have to look at the answer. No, because if you look at your work, then you can kind of figure out if it's 0. Right? Yeah. But the rule is, you don't look at the work. You just see what's on the answer. Just close it. Just close it. Okay, see you tomorrow.